Let's have a look at series and parallel circuits. There are two things we want to look at. We want to see how series and parallel circuits differ, and we want to see how is voltage and current distributed in a parallel circuit. Now, there's only one way of connecting a single light bulb to a battery. But a circuit with two light bulbs can be arranged multiple ways, two ways, series or in parallel. We've already looked at a series circuit, so let's look at the parallel circuits in contrast to series. Each arrangement, series or parallel, results in a different set of properties in the circuit. So let's just review the basics of a series circuit. We have three light bulbs in this example connected to a battery in series. And we see that we have a single loop here. So all coulombs of charge travel through the first bulb, through the second bulb, through the third bulb, and back into the battery. That makes that a series circuit. Electrons require a complete circuit or pathway from the battery to the bulb back to the battery. That's a requirement. Otherwise, the circuit would be open and the electrons or the charge cannot travel. If a light bulb is broken or removed from the circuit is no longer complete and none of the light bulbs will light up. They will all go out. So if we break that, remove that, then the current doesn't have a loop through which it can flow. So that would be a broken circuit or an open circuit. So let's look at a parallel circuit. And a parallel circuit would contain two or more light bulbs. And in this example, we will use three light bulbs, all connected in parallel. You can see that they're connected in parallel because the wires branch off a main loop like that. So they're all parallel to one another. So let's just follow the current flow before we get into the specifics. We start at the battery. You see the current comes out of the battery and hits a junction. And because it hits a junction, the current can split. So some of it goes into one light bulb and the rest of it continues on. And in this case, it hits a second split, and some of that current goes into the second light bulb, and the remaining current makes it all the way to the third light bulb. Now, traveling back to the battery, this current meets up with the current coming out of the second bulb, so they reconnect, they add up, and then that travels to this junction, which meets the current coming from the first light bulb, and all the current is back together, flowing back into the battery. So at each junction, we have a splitting of the current or reunification of the current. So some of the coulombs of the charge go through the first bulb, and some of it goes to the second bulb, etc. Each bulb has its own circuit or loop with the battery to the light bulb and back to the battery. So if we look at this light bulb here, we can see that we can trace out with the red line that we have a continuous loop. So that light bulb should light up in that circuit. Now if we ignore everything else, ignore the other bulbs and look at the second bulb, we can see that the second bulb also has its own loop with the battery. Okay, the other loops are there, but what's important is to see that that second light bulb has its own unique loop for current to travel. And the third bulb also, start at the bulb, go like that, goes through the battery, and returns back to the third bulb. So each bulb has its own loop. Now, if one of these bulbs were to break or to be removed, the other bulbs are still lit. And that's because each bulb has its own loop. So if we were to, say, remove this light bulb, it burns out, you can see that, well, the loop for the first light bulb still exists, so it's still going to be having current moving through it. And the third bulb has that large loop like that, so it should receive current also. Now, if one of the bulbs is removed, the remaining bulbs will actually glow brighter. You see, the current coming out of the battery here, it splits, and it was supposed to split here, but it doesn't. So that means that some of that current can continue on, and the light bulbs will glow brighter as a result. Now the voltage in a parallel circuit with a 6-volt battery, like our previous diagram, and 3 resistors in parallel. Each resistor gets 6 volts, but only some of the current. So that's because the current splits, but the voltage doesn't split. So the total voltage to each resistor is equal to the voltage of the battery. So in a parallel circuit, whatever the voltage of the battery, the voltage across each resistor, each parallel resistor, is going to be the same voltage of the battery. So in the case of our example, it was 6 volts. 6 volts coming out of the battery, 6 volts across each resistor. So that gives us this formula, that the total voltage, or the voltage across the battery in a parallel circuit, is going to be, they're all going to be equal to one another. And that's because the resistor forms its own loop with the battery. Now current in a parallel circuit, in this case I've only drawn 2 light bulbs, that's sufficient to show you what happens. So although the voltage is the same for each resistor, the light bulb serves as the resistor, each resistor requires its own share of current, and current is coulombs per second. So as the current leaves the battery, it splits at each junction. Some of the coulombs go through the first bulb, so we have a split right there. We talked about that earlier. So the current comes out of the battery, hits the junction, splits. Some of it goes to the first bulb, the rest of it goes to the second bulb. So while the rest goes to the second bulb, or bulbs, depending on how many bulbs you have in that series, that parallel arrangement. So consequently, what happens is because of the splitting and because the current comes back together, the total current in the battery or coming out of the battery in a parallel system, they're all going to add up. So the current going through the first bulb plus the current through the second bulb is going to add up to the overall current coming out of that battery. So just to summarize the formulas for the series circuit versus the parallel circuit, we have in a series circuit, the voltage adds up, so the voltage across the first light bulb plus the voltage across the second light bulb will equal the voltage of the battery. The current, however, will all be the same. So the current through each individual light bulb in a series circuit will be whatever the current is coming out of that battery. In a parallel system, however, the voltage coming out of the battery is going to be equal to the voltage across each light bulb in that circuit. However, the current adds up to the total current coming out of that battery.